Welcome to The Explainer. Today, we're unpacking one of the most powerful emerging technologies out there, the digital twin. We're going to get into the hype, the how, and what's happening right now.
So, first things first, let's just talk about the scale here, because it's staggering. By 2032, the market for this technology is expected to just explode to nearly $260 billion. And you know, a number like that tells you something really important. This isn't some niche concept. It's a massive, foundational shift in how whole industries are going to work.
And there's a really powerful reason for that explosive growth. Major studies like this one from McKinsey show that companies are using this tech to slash product development time by 50%. I mean, just imagine being able to test and perfect a new car or an airplane in a completely virtual world before a single physical part is ever made. That's a game-changing advantage for sure.
But, okay, beyond the big numbers and the impressive stats, what are these things really? And how do they actually pull off these incredible results?
All right, let's dive in. To really understand how they work, we got to start with the fundamental blueprint of a digital twin. And it all begins with one absolutely crucial ingredient: data.
At its core, a digital twin is a dynamic, virtual replica of a physical object. It could be a jet engine, a sprawling factory, a car, or even something as complex as a human heart. But here's the key. This is not just some static 3D model. Think of it more like a living, breathing digital echo that's constantly being updated with real-time data from its physical counterpart. And while digital twins are popping up in all sorts of fields, their adoption is really being led by what's known as Industry 4.0. That's basically a fancy term for smart manufacturing. We also see them transforming smart cities, by modeling traffic and services, and revolutionizing healthcare by making things like personalized medicine a reality.
So, here's the most crucial point. For a digital twin to be a true, living mirror of reality, it needs a constant, unbroken stream of data. And managing that absolute fire hose of information is by far the biggest challenge.
For a digital twin to actually work, it has to overcome some major data hurdles. First, you got to get uniform access to data from all over the place. Then you have to integrate it, combine data from all these varied sources. On top of that, you have to ensure the quality is there, that it's accurate. And after all that, you still need to be able to search and discover the right piece of info when you need it. It's a massive challenge.
Okay, so let's say you've wrangled all that data. The next challenge is building an engine powerful enough to process it. How do you create a simulation that can handle millions of moving parts in real time?
Well, when you try to run a simulation of a really complex system, like a whole city or a global supply chain, on a single computer, you just inevitably hit a wall. It's a problem called simulation slowdown. And honestly, you can think of it like the worst video game lag you've ever had, where the system just can't keep up with reality.
So, the old way of doing things, trying to run a massive simulation on just one computer, it just doesn't work. It completely falls apart. The solution is to think differently, to use a distributed approach. Instead of one giant machine, you use a whole network of them, and each one works on a small piece of the puzzle.
And to solve this, researchers have developed these incredible systems like SEED. You can think of it as a super smart traffic controller for the simulation. It automatically divides that enormous virtual model into smaller, manageable pieces and then sends them out to a network of computers to be processed all at the same time.
And this chart right here brilliantly illustrates the difference. On a single machine, a complex simulation runs 309 times slower than real-time. It's practically useless. But when you distribute it across 40 machines using a system like SEED, that slowdown drops to just 8.5 times. It's a night and day difference, a totally game-changing improvement.
So, we have the data blueprint and the simulation engine. But how does an organization take this powerful technology and actually scale it for long-term success?
Well, success with digital twins really follows a 5-step playbook. 1. Get creative and find new areas where they can add value. 2. Have a solid plan for scaling your tech and training your team. 3. You have to lock down your data security. It's your most valuable asset. 4. Measure your results to see what's actually working. And finally, number 5, you got to keep innovating to stay ahead of the curve with trends like AI and XR.
And this playbook really shows that putting a digital twin in place isn't just a one-off project. No, it's a long-term strategy. It's about laying the groundwork for the future of your organization.
And that future is all about making these twins smarter and way more immersive. We're talking about twins that use machine learning to learn and adapt on their own, and using extended reality, or XR, so engineers can literally put on a VR headset and step inside a virtual prototype and interact with it like it's real.
So, what's the bottom line here? Digital twins are no longer some futuristic curiosity. They are rapidly becoming the data-driven backbone of modern industry, and they're fundamentally changing how businesses design, operate, and compete.
And that brings us to a final, fascinating question to think about. If this technology had absolutely no limits, if you could create a perfect, real-time virtual replica of anything in the world, what would you choose to build?